In this video, I'm going to show you how you can use what I call a sign line for determining what's going on with quadratic inequalities. Let's take a look at an example. If x squared plus x is greater than 12. So my first step is going to be to get all of the terms on one side. So I have x squared plus x minus 12 is greater than 0. All right, so I want 0 on the right hand side, everything else on the left. My second step is going to be to factor my quadratic. So that's going to factor to x plus 4 times x minus 3, and now that's greater than 0. Okay, so I need to figure out, in essence, when each of these factors are, both of them are positive and both of them are negative, because of course then their product would be greater than 0. But in order to do this, I need a systematic way, so I'm going to use a sign line. So I have here x plus 4 times x minus 3 is greater than 0. I'm going to make myself a number line. And on this number line, I'm going to put all the places that the factors are 0. So x plus 4 is going to be 0 at minus 4. And x minus 3 is going to be 0 at 3. And then I'm going to just put above that there's 0 there. Then I'm going to list my factors on the left-hand side. So I have x plus 4. I have x minus 3. And now what I'm going to do is, you notice that this number line has been broken into 3 regions, 1, 2, and 3. I'm going to pick a test value for each factor in each of those regions, understanding that whatever the sign of my factor is in each of the region, for one value, it's the same for all the values. So for example, looking at x plus 4, I know it's 0 at minus 4. If I pick a value to the left of minus 4, say minus 5, then I know that minus 5 plus 4 is minus 1. So since it's negative on the left of minus 4 for minus 5, it's negative for all values over there. Pick a test value in between minus 4 and 3, say 0. 0 plus 4 is 4, so that's positive. So everything in between minus 4 and 3 is positive. And pick a test value to the right of 3, say 4. 4 plus 4 is 8, which is positive, so everything for that factor on the right of 3 is positive. Let's do the same thing for x minus 3. At 3, we have 0. Pick a test value to the right of 3, since we're there, say 4. 4 minus 3 is 1, and 1 is positive, so everything to the right is positive. Pick a value between minus 4 and 3, say 0. 0 minus 3 is minus 3, which is negative, so everything in between minus 4 and 3 is negative. And then pick a test value to the left of minus 4, say minus 5, and minus 5 minus 3 is minus 8, so everything to the left is negative for the factor x minus 3. So now notice what I've done with these two rows here of minus and plus signs. I've determined when each of my two factors are negative and positive. And so my inequality up above is asking me to find all of the x values for which x plus 4 times x minus 3 is greater than 0. So let's see what happens here. On the left of minus 4, I have a minus and a minus, which makes a plus. In between minus 4 and 3, I have a minus and a plus, which makes a minus. And then to the right of 3, I have two plus signs, which makes a plus. Let me just capture this here, and I'm going to move it to another slide, and then we can analyze it finally. So, for my factors, I see that x plus 4 times x minus 3 is greater than 0 from minus infinity to minus 4 and from 3 to infinity, not including those endpoints because I was looking for the place where x plus 4 times x minus 3 was greater than 0, not equal. So I can write that now in interval notation. I know that this is true from minus infinity to minus 4, parenthesis because the minus 4 is not included, union with 3, not included, so parenthesis there, to infinity. And now I know where x plus 4 times x minus 3, or what started as x squared plus x, is greater than 12.